Hey guys, welcome to question FM198 of the Further Maths Fortify study guide. This question reads, Sarah breeds frogs in her spare time. She keeps the tadpoles in a tank while they develop. As they mature, Sarah moves the frogs to an enclosure before periodically releasing them into the nearby wetlands. Let Tn be the number of tadpoles in Sarah's tank at the start of the nth month. The change in the number of tadpoles from month to month can be modeled by the recurrence relation Tn plus 1 equals 1.35 times Tn minus k, where T1 is equal to P, where P is the number of tadpoles in the tank at the start of month 1. Let Fn be the number of frogs in Sarah's enclosure at the end of the nth month. The change in the number of frogs from month to month can be modeled by the recurrence relation Fn plus 1 equals 0.55 times Fn plus k, where F1 is 540. Explain, question A says explain the meaning of K in the context of the above scenario. So we have these two not little equations, we've got these two equations here. We've got Tn plus 1 is equal to 1.35 times Tn, which means that what happens first here is our tadpole population increases by 35%, and then we've got this minus K, which is some constant that's it appears to be being removed from this population. And since we were told in the context of the question that we have, as the tadpoles mature and turn to frogs, Sarah moves the frogs to an enclosure. So we can assume that this minus K is probably those frogs that are being moved over to the enclosure, where T1 is equal to P. And then down here we've got Fn plus 1 equals 0.55 times Fn. So here we've got a decrease in the frog population, which once again, according to the context of the question, Sarah moves the frogs to an enclosure before periodically releasing them into the nearby wetlands. So this percentage decrease is probably the frogs that are being released back into the wetlands. And that stays consistent with the fact that we're minusing an amount and that same amount is being added to our frogs. So we're minusing a certain amount from our tadpole population and moving that to our frog population. We can pretty readily assume that that's what K represents. That is the tadpoles that have matured and are being moved over to the enclosure, where F1 is equal to 540. Excellent. So we would write something along the lines of K is the number of tadpoles which have turned into frogs that are moved from the tank to the enclosure. Something along those lines. On to part B. Part B says, find the value of P such that Sarah will have 20% more tadpoles in month 2 than month 1 and 10% more frogs in month 2 than month 1. Now, if we were to look at these recurrence relations that we've got up here, if we want to know a value for P, if we're going to try and solve a value for P in this top tadpole equation, then we're going to need to know a value of K. And the easiest way for us to find a value of K is going to be by using this frogs recurrence relation, because the only unknown variable in this one is K. So what do we know about the frogs? Well, we know that the number of frogs after the first month is 540. And we can calculate the number of frogs from the second, at the end of the second month, because we were told that we're trying to find the value of P that's going to result with 10% more frogs in month 2 than month 1. So we could have an equation that says 0.55 times 540 plus K, we still don't know, and we know that this is going to be equal to 1.1 times 540. So this 0.55 times 540 plus k comes from the recurrence relation. We know that f2 is going to equal 0.55 times f1 plus k. We're going to try and see if we can figure out what k is. We also know that the answer is going to be 10% more than month 1, which means if we apply this 1.1 times 540, that will increase 540 by 10% and hopefully get us 594. Plugging this equation into solve, 0.55 times 540 plus k equals 1.1 times 540. Solve for k. We should get an answer that says k is equal to 297. So now we have a value for k that we can use in our tadpoles equation to help us find that value of p. So what do we know about our tadpoles? Well, t1 is p, and t2 is going to equal 1.35 times t1 minus k. We also know that t2 is going to be equal to 20% more than in month 2 than it is in month 1. Now in month 1 the value is p, so in month 2 it's going to be 1.2 times p. That will apply a 20% increase to the value of p. Inserting all the bits that we know, we get an equation that says 1.35 times p minus, and k we found to be 297 before, 297 equals 1.2 times p. So if we solve for this equation, solve, comma p, that should drop out a value of p that says 1,980 tadpoles. So that is our value of p, 1,980. Guys, if you have any questions about our answers here, please drop them in the comments below. Otherwise, I'll see you in the next video.